again, both of them, they adsorbed it on the same type of site. So on the solid surface of the catalyst, only one type of site, okay? And A and B will be adsorbed on the site, okay? So the rate is equal to K times theta A times theta B. And with this, we just account for all the species on the surface, okay? So you can see here, like you look at the denominator of the Langmuir-Joule-Hagen-Watson rate expression. 1 represents vacant site, right? KAPA represent A, adsorbed, right? KBPB will be adsorbed B, KRPR will be adsorbed R, KSPS adsorbed S. So on the surface we have A and B the reactants and R and S the products, okay? And you have the whole thing squared. When you have the whole thing squared, that means there are 2 sites involved, okay? The 2 sites involved because we have K times theta A times theta B, right? So 2 sites involved, so the exponent in the denominator represent the number of sites involved. And then we discuss what the rate looks like as we vary the partial pressure of the reactants and then keep the other one constant. So this one will go up and come down and reach the maximum, okay? And this is when what we get if we have 2 molecules of A react with one another, right? This is different, so it will be A plus A, okay? So there's no B, it's only A in here, okay? So this will be the rate expression you get. We already talked about this, so I'll just like recap what we did, okay? Before we move on. Then case number 3. Case number 3 is irreversible bimolecular reactions. So again, 2 molecules, okay? But now the reactants, they are adsorbed on different type of sites, okay? That means, for example, we have metal oxide as a catalyst, right? There will be a site at the metal atom, and there will be another type of site at the oxygen atom. It's possible, right? And then, again, this is a chemisorption, right? So chemisorption requires like a matching between the adsorbent and adsorbate. So some molecules might prefer to adsorb on the metal side. Some molecules might prefer to adsorb on the oxygen side, okay? So it's possible. Or some molecules just adsorb everywhere. It's fine. Possible too, right? So this one, let's say we have the A adsorbed on type 1 site, B adsorbed on type 2 site. So the rate becomes the K times theta A on type 1 site, so A1, and theta B2, so B adsorbed on type 2 sites, okay? So if you have more than one type of sites, the key thing is to, again, you develop the Langmuir isotherm using the equilibrium relation, right? But then when you do the site balance, you do it separately, okay? You do type 1 site, and then you account for all the stuff that adsorbed on type 1 site, okay? And then you, in a separate balance, you do type 2 sites. So you account for what is adsorbed on type 2 sites. You don't mix them, okay? You don't mix them. So it will look something like this, okay? If we disregard or we neglect the R and S on the surface, okay? So we'll have something like this. So those are the 3 cases that we discussed last week, okay? So we will try to finish case number 4 and 5. Okay. Case number 4, irreversible bimolecular, 2 molecules again, right? But this one is different because one species adsorbed on the surface. The other one is in fluid phase. Okay. So which one is on the surface? Okay, B, A on the surface. So we have A here, right? And have B in the gas phase, something like this. And they react with each other. Okay? So, again, you starting the process with the adsorption of the reactant. So, A plus sigma, which is the vacant site. And then you have A dot sigma, which is adsorbed A, right? And then the adsorbed A reacts with B in the fluid phase. Irreversible, right? And what you get? R. Okay. So if we will have adsorbed A reacts with B in the gas phase. So the left-hand side only involve one side, right? One adsorption side. So the right-hand side will only have one side. Okay? So either R or S needs to go out in the gas phase. Okay? No spot for you. All the sides are taken. Okay?
So it must be gas, right?
What?
So either A or B must be gas.
For this mechanism, yes. So this mechanism we call radial mechanism. So it's one species on the surface, the other one in the fluid phase. Okay. Yes. A, there will be A. This is A in fluid phase, but it adsorbed first before it reacts.
So either A or B can be fluid or...
No, A and B, they are in gas phase already, right? But A adsorbed first before reaction. But B doesn't need to adsorb. B can react with adsorbed A as a gas molecule, okay? And then we have desorption of R. Okay. So here, 3 steps, right? Adsorption, surface reaction, and desorption. Okay? And this, we still said that the surface reaction is the slowest step, right? So this rate limiting step. So the rate for the whole thing would be, based on this one, would be K times A on the surface, that represented by theta A. But B is in gas phase, so it will be PB. Okay? So, elementary, right? First order with respect to adsorbed A, so we use theta A. First order with respect to B in the gas phase, we use partial pressure. Any question? Well, I'm getting new one too. A new surface. No, I just try to use money before I retire or die. Okay, so for PB, we leave it as is, right? But for theta A, again, we do the Langmuir adsorption, right? That Langmuir isotherm. So we have step 1 and step 3, and we assume that all the adsorption and desorption are in equilibrium, right? So that means that for step 1, we can write theta A equals to Ka, Pa, theta V, right? And then for this one, we write it as the adsorption as well, theta I equal to Kr, Pr, theta V. Then we do the side balance. So 1 equals theta V plus theta A plus theta R, right? Only A and R on the surface in this mechanism, right? But another possibility is like a B can absorb as well, but only B in the gas phase can react. Okay, so it depends. But this is the simple version. So B only stay in the gas phase, no absorption. Okay, but life can get messy. So you need to be prepared for that. So theta V, right? And then theta A, plug in there, Ka, Pa, theta V, R, which is Kr, Pr, theta V. Again, you extract theta V as a common factor, and then you get theta, solve for theta V, which is 1 over 1 plus Ka, Pa plus Kr, Pr. Okay. The process is similar, right? You just need to look at the detail. Look at the details. Like what's going on in the mechanism. And then, again, keep in mind that all the steps are elementary, right? So you can write down the rate right away. And once you know theta V, you plug it in there, you get theta A, right? So you have K for theta A is Ka, Pa times theta V, which is this thing. 1 plus Ka, Pa plus Kr, Pr. And then you have Pv here. So this is the rate. Any question? Yes.
The P gas does not absorb, it just stay there on the surface of air.
What? Which gas?
You said before, the P thing does not react,
Oh, B may absorb, but only B in the gas phase will react in this reaction. Nobody forbid B to absorb. Okay, if they want to absorb, you can absorb, but only B in the gas phase can react with absorbed A. Okay. Absorbed B, which is be there, just stay on the surface. So we have one more term, KBPB in the denominator, if B absorbs, right? So if we again okay, if we vary the partial pressure of the reactant, only one reactant and keep the other one constant, what will the graph look like? Think, because I still have the randomizer from cost view now. Huh? Well, you say the same thing on Thursday, and I only called 2 people. You are one of them, so I don't think your luck's not that good. My trinket is stronger. Okay, think, because I will ask. This was not that difficult. Okay, today is the 15th, so we open door number 15. Okay, I just make an announcement. This afternoon class will be postponed to Friday. Okay, You can join me at the ตลาดเที่ยว for fun later.
อาจารย์ครับผมเที่ยววิวลาสติลเวน
4, I think.
just for
Yeah. But then you can go cheer me on in the auditorium at 3, okay?
after finish my ride
Oh, whatever.
แล้วคุณไอ้เดลิเวอรี่คุณโกรธอาจารย์จะเฉยเอา
I need somebody to take my photo so I can post on Instagram. Okay, pick a who. Today is the 15th of October. Ken, not here. Okay, so October day number 10. Chanachan. Oh, well, I
แล้วเดย์
no, you just like maybe cause you love you. Say it show. ฮะ
มึงโดนอาจารย์เลิกที่สองมึงโดนดิ
No, the date is 10/10.
Can you have me two for me that's one now
ฮะ
just try to get two for me
You're 22 or 24?
ถ่ายแล้วครับ
24?
ถ่ายของถ่ายถ้ามันถ่ายมาก
See?
ไม่ได้ไม่ใช่
No
ไงดูลัคกี้ไง
See? Don't blame the program. Okay? So what will it look like?
Which one? Upper or lower?
You have to do both. It's easy lah.
I think both brown would be the same thing, right?
Really?
I don't know. Just guess.
Huh? No, you don't guess. You look at this and you answer. No guessing. We engineer, we don't guess. We know, we learn things. We don't guess.
One PB PD system. So it depends on.
So which one? You're talking about the top one or the bottom one first? Top one, what will it look like?
The PB is constant, so rate is proportional to say the A. So it should be linear.
This? You increase PA and then it's linear?
I look at the first expression. The K.
This one, this is the final rate expression, right? You look at the rate versus PA. So you have to look at this one.
It should be something before.
Huh? No, not linear all the way though, right?
But not all the way at first,
Yeah.
low pressure.
And then what?
And then how do I like? Linear flat.
แรปเปอร์
It looks like linear isotherm. Okay. Easiest way to describe this is linear isotherm. So what does this one? What this one? My hint is they don't look the same.
So it should not be linear
Why not?
because PA is constant. So
Yeah, the whole thing is constant.
it should be K PB over K RPR.
Who cares about KRPR? We marry PB, right? So it should go up as linear all the way. Right? But everything else constant, so the rate is proportional to PB to the first power. So go up, doesn't flat. Okay? Any question? Why am I hungry? No, cannot eat what teaching.
so that's what is the linear
That's not a very good manner.
อาจารย์ครับอันนี้ลิเนียร์ใช่ไหมครับ
What?
ที่มันลิเนียร์อะไรที่มีเองเหมือนกันครับ
Which one? Top one or bottom one?
ว่าช่วงบน
Bottom one keep going up. keep going up.
In
That,
the over.
yes, it's PE to the first power. Okay? And they said if you consider a general case where all the species may absorb, okay? So we might have adsorption of B and also adsorption of S on the surface. But again, only B in the gas phase can react with adsorbed A, okay? But anything can adsorb on the surface, but this adsorbed A reacts with gas phase B, okay? The rate expression looks something like this, okay? But if we switch around, this has adsorbed B reacts with A in the gas phase, right? You see that these two, they look the same. Essentially the same, right? You think that this is like just constant, so they look the same. So you actually cannot tell which one is correct. Okay, you might need to do something else to determine the mechanism. Okay, just from this plot, well, let's say because this one will have because they will both look something like this. Langmuir isotherm PA or PB changing, they look the same. Okay. So if you do an experiment, you see the rate going up linearly and then flatten out, you cannot tell which rate expression is correct because they give you the same plot, right? So you must do something else.
So we have to other experiments or we just
I don't know. No, but then this one, you cannot use this to distinguish between the two mechanisms. You have to do something else. Okay. Said if the surface is nearly covered, mean theta A is about 1, so that means only, okay. So if it's covered by A, right? So the dominant term will be this term, okay? So the rate will be first order with B and zero order with A. See that, right? Because everything else gone. So if this term dominates, right, then we neglect the rest, and then we have the rate to be K times PB, right? So the surface is almost all A, then we have the reaction to be first order with respect to B, okay? And there's no A left. But then, if the surface is sparsely covered, I don't think this is correct though. It should be sparsely covered means like a lot of vacant site, right? A lot of vacant site. So the dominant term will become 1 instead. So if the dominant term becomes 1, right? This whole thing disappears. So you have the rate to be first order with respect to A and first order with respect to B, second order overall. Okay. Any question? or say since absorption is always exothermic, so the first condition where A is almost covered by the surface covered by reactant, that means low temperature. Low temperature, right? Because at low temperature there are a lot of absorption, a species absorbed on the surface. But at high temperature, the absorbed species will get removed from the surface. So become that there are more vacant site. Okay. So this mechanism offers some explanation of a transition from first order to second order, okay, with the increasing temperature.
เป็นไงกับนี้เนี่ยครับ
Any question?
ดูแปลกที่มันมีแบบมาเปรียบเทียบบางทีมันก็เปรียบเทียบว่าโคตรกับเราของร้านนี้กับร้านนี้ทำต่างกัน
Okay. Now we come to case number 5. Okay. Case number 5
ถ้าเรื่องความให้กิน
would be the first reversible that we discussed in this chapter. So reversible reactions between absorbed species, but then there is a change in number of moles. Okay. You can see left hand 1 mole, right? Right hand 2 moles. Okay. There's a change in number of moles. All species are absorbed on the surface side. Then we have absorbed A reacts with vacant site, and then we have absorbed R and absorbed S as the product. Okay. Again, you can see that the number of sites involved on the left-hand side are 2, and the number of sites on the right-hand side are 2 as well. So both sides must have the same number of sites. Okay.
เขาบอกว่าถ้ามันไปรูปแบบแรกจะกินสี
So if you do this,
รอบ
างทีต่อกันจะเป็นใช่
so you have A as reactant, right? So you start the reaction by absorption of A plus sigma, go to absorbed A, and then absorbed A with vacant site. If you are absorbed plus S absorbed, then you will have the dissolvation of the product.
แต่นี้มันเป็นแบบไม่ได้แพง
แต่นี่ก็300 กว่าบาท
Okay. So you have the first step, absorption of reactant, right? Second step, reversible reaction on the surface of the catalyst. And then the last 2 will be dissolving of the product. Okay. And again, surface reaction is rate limiting step. Ooh. Which one is this?
มันเป็นเอาคาโด
I might step on it.
สไปซี่ซอส
No, put it down. Don't put it on the stage, put it down on the floor.
It's okay, it's a Richard waiting with you now.
Okay? So this is rate limiting step, right? But since this surface reaction is reversible, so when you write down the rate, it will contain 2 terms, right? The forward rate and the reverse rate. The forward is K1, right? Backward is like K minus 1. So again, elementary, right? So you can write down the rate right away. For forward rate, it will be K1 times absorbed A, theta A, vacant site, theta V, minus reverse reaction, K minus 1, the rate constant, and then we have absorbed R, absorbed S, so we have theta R and theta S. Okay? So when the rate limiting step is reversible, then you write down the rate. There are two terms, right? The forward rate, the front one, it's K1 times theta A times theta V, and then minus the reverse reaction, so K minus 1 times theta R times theta S. And then again, you assume absorption and desorption equilibrium in step 1, 3, and 4. Then you can write down the same thing, right? Same thing. Do the side balance, and then you get the rate to be, the theta views have something like this, right? Because it has A on the surface, R on the surface, S on the surface. And you plug theta V in, and you get something like this. I don't want to write down too many things. Again, look at this. So that means the denominator can tell you what's on the surface, right? You have vacant site, you have A, you have R, you have S. When you have square, means there are two species involved, okay? The left-hand side has adsorpted A and vacant site, right? The right-hand side has adsorpted R and adsorpted S. So two species involved on the surface. That's why we have square here. Okay? Any question with this? And then, if you do a little rearrangement, they said that, need to do it. If you pull KAPA out, then multiply everything by K1. Right? And that's what they did. Oh, only no PA. Okay. You pull K1, KA out, you're left with PA, right? And then the second term have K minus 1 divided by K1, and then have KR, KS, PR, PS. And this denominator is still the same. This is the you have it on the slide next page already, so no need. Okay, so this will look similar to what we have next slide. Yes. Yes. Let's have KA here. Thank you. So we have it here. Okay. And then for
เดี๋ยวไปขั้นตอน
still